According to the National Electrical Code, specifically Article 384.22, paralleling of service disconnect switches is permitted only if the following conditions are met. Firstly, the connected load is greater than the rating of any one service. Secondly, the neutral is paralleled and the grounded conductors are common. And thirdly, bonding is provided between the parallel disconnect switches and the enclosure containing them. And fourthly, the service disconnect switches are identified as paralleled and the maximum load that the paralleled services can supply. Paralleling service disconnect switches presents potential safety hazards if not done properly. Excessive current can flow through the jumpers if the voltage or phase angles of the two services are not exactly the same. This can lead to overheating, arcing, and potential equipment damage or even fire. Given an extended duration of a shutdown, it is not recommended to leave the services parallel for that period of time. While a room may be locked, it is possible that unauthorized personnel could gain access and inadvertently disconnect one of the services, leading to a loss of power to the facility. To avoid the inconvenience of removing and reinstalling jumpers, consider using a temporary automatic transfer switch to provide backup power during the shutdown. This would allow for a cutover to the backup service without interrupting power to the facility. The automatic transfer switch would also provide protection against any imbalances in voltage or phase angles between the two services. When paralleling electrical services, it is crucial to adhere to the National Electrical Code regulations outlined in Article 384.22. Firstly, the connected load must exceed the capacity of a single service. This ensures that paralleling is necessary to meet the demand. Secondly, the neutral conductors of both services must be paralleled and have a common grounding point. This maintains a stable and safe neutral reference. Thirdly, proper bonding must be established between the parallel disconnect switches and the enclosure housing them. This minimizes the risk of ground faults and ensures personnel safety. Fourthly, the service disconnect switches must be clearly labeled as paralleled, indicating the maximum load that the combined services can safely handle. Ignoring these requirements can lead to code violations and potentially dangerous situations. Paralleling electrical services introduces several safety considerations that must be carefully addressed. One major concern is the potential for excessive current flow through the jumper cables connecting the services if there are even slight differences in voltage or phase angles between the two systems. This excessive current can cause the jumpers to overheat, potentially leading to arcing, insulation breakdown, and even fires. Regular monitoring of the jumper cable temperature and current is essential to identify any signs of overload. Another hazard is the risk of accidental disconnection of one service while the other remains energized. This can create an imbalance in the system and potentially damage equipment. Clear communication and lockout-tagout procedures are crucial to prevent accidental disconnections during maintenance or repairs. Furthermore, ensuring proper ventilation in the service room is vital to dissipate heat generated by the paralleled services. Overheating can degrade equipment performance and increase the risk of failure. The recommendation to avoid leaving services paralleled for extended periods, such as 2 to 3 days, stems from the cumulative risk associated with the factors mentioned earlier. The longer the services remain paralleled, the greater the chance of encountering voltage or phase angle imbalances, accidental disconnections, or overheating. Even with a locked service room, the possibility of unauthorized access cannot be entirely eliminated. Someone unfamiliar with the system could inadvertently disconnect a service, leading to an unexpected power outage. Therefore, minimizing the duration of paralleling significantly reduces the overall risk. An automatic transfer switch provides a more robust and reliable solution for maintaining power during service shutdowns. The automatic transfer switch continuously monitors both service feeds and automatically switches to the backup feed if the primary feed fails or is intentionally disconnected. This ensures an uninterrupted power supply to the facility, eliminating the risk of downtime. Moreover, the automatic transfer switch offers protection against voltage and phase angle imbalances. It typically includes sensors that detect any deviations from acceptable levels and prevent the transfer if the backup feed is not within the specified parameters. This safeguards equipment from potential damage caused by unstable power. The automatic transfer switch also simplifies the process of switching between services. Instead of manually installing and removing jumper cables, the automatic transfer switch handles the transfer automatically, reducing the risk of human error and saving time. It is important to select an automatic transfer switch that is appropriately sized for the load and meets all applicable safety standards. Regular maintenance and testing of the automatic transfer switch are essential to ensure its proper functioning and reliability. When considering paralleling electrical services, it is paramount to prioritize safety and compliance with the National Electrical Code. Remember, the conditions outlined in Article 384.22 must be strictly adhered to. Firstly, verify that the connected load exceeds the rating of a single service. Secondly, ensure that the neutral conductors are properly paralleled and grounded. Thirdly, establish robust bonding between the disconnect switches and the enclosure. Fourthly, clearly identify the switches as paralleled and specify the maximum permissible load. Never compromise on these requirements, as they are essential for safe and reliable operation. Regular monitoring of the jumper cables connecting the services is crucial to detect any signs of overheating or overload. Use thermal imaging cameras or contact thermometers to check the temperature of the cables and connections. If any hotspots are identified, investigate the cause immediately and take corrective action. Additionally, monitor the current flowing through the jumpers using ammeters to ensure that it remains within the allowable limits. Implement strict lockout-tagout procedures to prevent accidental disconnection of either service during maintenance or repairs. Clearly label all disconnect switches and circuit breakers to avoid confusion. Train personnel on the proper procedures for isolating and energizing equipment. Provide adequate ventilation in the service room to dissipate heat generated by the paralleled services. Install exhaust fans or air conditioning units as needed to maintain a safe operating temperature. Consider using a temporary automatic transfer switch as a safer alternative to paralleling services for extended periods. This device automatically switches between the primary and backup service feeds, ensuring uninterrupted power supply. An automatic transfer switch also provides protection against voltage and phase angle imbalances. Remember that electrical work should only be performed by qualified and licensed electricians who are familiar with the applicable codes and safety standards. Always consult with a qualified electrical engineer to ensure that the paralleling of services is designed and implemented correctly. Never take shortcuts or compromise on safety when working with electricity. Failure to follow proper procedures can result in serious injury or death. Therefore, prioritize safety and seek professional guidance to ensure a safe and reliable electrical system. Paralleling electrical services involves connecting two or more electrical sources to supply a common load. While this can provide increased capacity and redundancy, it also introduces potential safety hazards. When paralleling services, it is crucial to ensure that the voltage and phase angles of the sources are closely matched. Differences in voltage or phase angle can cause circulating currents to flow between the sources, leading to overheating and equipment damage. To minimize these circulating currents, it is important to use transformers with similar impedance characteristics and to maintain consistent wiring practices. The National Electrical Code provides specific requirements for paralleling electrical services, including limitations on the number of sources that can be paralleled and the size of the conductors used. Adherence to these requirements is essential for ensuring a safe and reliable installation. Before paralleling any electrical services, it is recommended to consult with a qualified electrical engineer to perform a thorough system analysis. This analysis should consider factors such as load requirements, source characteristics, and potential fault currents. The engineer can then recommend appropriate protective devices and wiring configurations to mitigate any risks. Regular maintenance and testing of paralleled electrical services are essential for ensuring their continued safe and reliable operation. This includes periodic inspections of wiring connections, testing of protective devices, and verification of voltage and phase angle matching. Any deficiencies should be promptly corrected to prevent potential problems. It is also important to train personnel on the proper procedures for operating and maintaining paralleled electrical services. This training should cover topics such as lockout-tagout procedures, emergency shutdown procedures, and troubleshooting techniques. By following these guidelines, it is possible to safely and effectively parallel electrical services to meet the increasing power demands of modern facilities. However, it is important to recognize the potential hazards involved and to take appropriate precautions. Consider consulting with a qualified professional before undertaking any paralleling project. The potential safety hazards of paralleling electrical services should not be underestimated. Firstly, as mentioned, circulating currents can cause overheating and equipment damage, potentially leading to fires or explosions. Secondly, improper grounding can create ground loops, which can interfere with sensitive electronic equipment and create a shock hazard. Thirdly, unbalanced loading can cause voltage fluctuations and harmonic distortion, which can damage equipment and reduce system efficiency. Fourthly, inadequate protection can leave the system vulnerable to fault currents, which can cause widespread damage and pose a serious safety risk. The National Electrical Code addresses these hazards by providing specific requirements for grounding, bonding, overcurrent protection, and conductor sizing. These requirements are designed to minimize the risk of electrical shock, fire, and equipment damage. For example, the code requires that all metal enclosures be properly bonded together to create a low impedance path for fault currents. This helps to ensure that protective devices will quickly trip in the event of a fault. The code also requires that overcurrent protection devices be properly sized to protect conductors and equipment from overload and short-circuit conditions. Furthermore, the code specifies minimum conductor sizes for paralleled conductors to ensure that they can safely carry the expected load current. In addition to the code requirements, there are several best practices that should be followed when paralleling electrical services. Firstly, it is important to use high-quality components and equipment that are designed for paralleling applications. Secondly, it is important to carefully plan and coordinate the installation to minimize the risk of errors or omissions. Thirdly, it is important to thoroughly test the system after installation to verify that it is functioning properly. Fourthly, it is important to provide ongoing training to personnel on the safe operation and maintenance of the system. By following these best practices, it is possible to create a safe and reliable paralleled electrical service that will provide years of trouble-free operation. However, it is important to remember that electrical work can be dangerous and should only be performed by qualified professionals.